In our measurements lab project, we did an experiment over solar powered fuel cells. My name is Jared Brooks,
I'm Nick Johnson.
Guillermo Verdun.
and our cameraman is Kevin Johnson.
So, a little bit about our history. In 1842, William Robert Grove invented the first hydrogen fuel cell. It really wasn't ready for production until years later, and you can see that in 1960, NASA used the first fuel cells in their space missions, and then 20 years later, the U.S. Navy had fuel cells to power their submarines. 1990 marked the year when commercial and industrial locations started using large stationary fuel cells. And then nearly 18 years later, Honda began producing and selling fuel cell powered electrical vehicles for public use.
In our lab, we use high-tech Eco H2 to generate hydrogen and discharge electricity in two separate experiments. In experiment 1, we measured the time to generate 10 centimeters cubed of hydrogen. In experiment 2, we measured time and voltage during the discharge of the 10 centimeters cubed from our previous experiment. And right here is a diagram of what our hydrogen fuel cell looked like. In the diagram, it displayed a solar panel that was attached to the fuel cell, but to get more accurate results, we used the power source, which is this low voltage AC, DC power supply. And to get our readings, we used the voltmeter.
This is the results from our first experiment. We had our voltage supply set at 1.6, our current was 0.36, gave out a power of 0.576, and to produce 10 centimeters cubed of hydrogen, it took 202 seconds. It's a little bit more than 3.5 minutes. And then for our second experiment, we took that same 10 centimeters cubed of hydrogen and we discharged it to produce electricity. Here's our current for every minute it was discharged, and our voltage and the power it put out. And it took about 12 minutes to use up all of the hydrogen. Here's our averages. For our average current, we got 0.0475. Voltage was 0.62775, and average power was 0.02987. For our efficiency for the power of being put in and put out, it was 5.1%, but our voltage, it came out to be 39%. So we lost most of our efficiency from our low current from the hydrogen. And this also shows, this is just a graph of the voltage throughout 12 minutes, and it shows it's pretty consistent, no really big spikes.
Alright, so from this project we were able to gain a greater understanding how the hydrogen fuel cell worked. It was pretty neat because they've always been a really interesting thing, but now we actually know what makes them tick. As Jared said, our efficiency was only about 5%, and that's comparing the amount of energy that we had to put into the system versus the amount of energy we got out. That's not the actual efficiency of a hydrogen fuel cell itself. Now, reason for such a low efficiency, because that is very low, even by normal standards. The rig that we use is about 12 years old, and we have relatively polluted air down in our area. But you can definitely see that the conversion of hydrogen to hydrogen fuel cell will definitely be a driving force for future means of clean, energy efficient energy.
If you have any questions, leave them in the comments below.